Extrema. The objective of this video is to determine the maximum and minimum of functions. So we're basically going to look at points that are known as critical points of a function, which is where we can basically draw a line that's tangent, meaning like a straight line that only touches one specific point of the curve. So at minimum or maximum points, this is happening. So basically, I can take a line and I can just draw, and it touches the graph at one specific point. It does not intersect anything. So these are called maximum and minimum points or critical points. So we want to determine any extrema points. So we're thinking about absolute maximum, absolute minimum, relative minimum, relative maximum. So relative min means to the left or to the right of the point, everything else is getting bigger. It's increasing. Relative max means to the left or to the right, everything is decreasing. So, for example, at this point, negative 0.5, we are decreasing to the left, decreasing to the right. So this point is a relative max. So at x equals negative 0.5, we have a relative max. Then at this point, 1, we have a relative min because to the left it's increasing, to the right is increasing. So in comparison to what's happening, it is relatively smaller than other things in the graph. However, it's not an absolute min or an absolute maximum because it is not the lowest point of the entire graph. I can go lower because down here, this is lower than that point, and up here, this is higher than my relative max. So there is no absolute minimum or maximum in this function because this is going on to infinity. So there are none for that. Again, just like increasing or decreasing intervals, we want to state what's happening in terms of x. So we're focused with the x values to state the relative minimum or maximum. We can also support our answers numerically by looking at a table. Because this graph was very clear, it wasn't necessary to really look at the table. However, some graphs, you might need to focus in on certain numbers because we won't be sure what's happening. So if you look at the numbers numerically, you could tell that in comparison to what's happening to the left and to the right, this is relatively maximum to what's happening to the left and to the right of this number. And this is a relative min because to the left and to the right, we have numbers that are higher. So now you try. You're going to use a graphing calculator to input the functions in your calculator and determine any extrema points by stating the x values where this occurs. Pause your video, then press play to see if your answer is correct. Pause your video now. So when I look at my first one, I actually just have an absolute max because I basically have an upside down parabola. So there's just one absolute maximum point. Everything else, there is none. For my second function, I end up with basically like a little squiggly because this is a polynomial to the third degree. So I am going to have 3 zeros. So I do have a relative min at one of the lower loops and a relative max at one of the other loops. However, there is no absolute minimum or maximum because it goes on to infinity in both directions. As you can see, most of my x values are not exactly whole numbers. I did use my graphing calculator to find the exact minimum and maximum values. If you're just looking at this graphically without a graphing calculator, you're going to have to use the estimation method to kind of determine what number is it closest to. However, to be more accurate, you're going to want to use your graphing calculators.